All right, Advanced Math 8, here we go. We've got slopes of parallel and perpendicular lines, lesson 3.1.3. So we're starting off with something we've kind of seen before. It says, describe the relationship between PQR and P prime, Q prime, R prime. So I think that a lot of you would look at that and go, that looks like a reflection. And it is a reflection. Because remember, a reflection keeps the distance from the point to a line. So what I want to show is that we could actually draw a line from R to R prime. And look at that, that makes this beautiful 90-degree angle right there. And if we do the same thing from Q to Q prime, again, it's going to make this really pretty 90-degree angle. Isn't that lovely? It is. And then if I did the same thing for P to P prime, I've got another beautiful 90-degree angle. Okay, so why are these 90-degree angles? Because when I measure a distance from a point to a line, the fastest way to go from the point to the line is at a perfect 90-degree angle. Like if I went from the point to over here, that's not the fastest way possible. Fastest is just the direct approach going directly across here. So what we notice here is when I reflect over this diagonal line, I get perpendicular lines for these distances here between the pre-image and the image. So the relationship between them is it's a reflection. All right, we're going to take that and kind of build off of it today because we're going to be talking about parallel and perpendicular. All right, so this one says on the next one, on a piece of paper, graph y equals 3x, 3/5 x minus 4. Okay, I got to stop rushing. Here we go. So I'm going to take out a piece of graph paper. Let's see. I don't know, right about here maybe? Or here? Yeah, let's do here. All right, so I've got 3/5 x minus 4. So the y-intercept is -4, so I'm going to go down 1, 2, 3, 4. So first point, my slope is 3/5. So the change in y is 3, so up 1, 2, 3, and change in x is 5. 1, 2, 3, 4, 5. All right, so we get, I guess I could also go down 3. 1, 2, 3, and backwards. 1, 2, 3, 4, 5. There we go. There's another point. All right, so done problem. What else do you want me to do? Let's find out. Let's see. Next thing it wants us to do is translate the line up 5 units. So when we translate up, we're just going to take each point and move it up 5 units. So I'm going to take this point and go up 1, 2, 3, 4, 5. There's that one. This one's going to go up 1, 2, 3, 4, 5. And this one would go up 1, 2, 3, 4, 5. So all the points have been moved up 5 units. And here is the translation of that line. So we've translated that line. There that beautiful thing is. All right, what's the equation of the image? So this was my pre-image, and then in red is my image. Well, we've got the y-intercept. So I know this is going to be y equals something x, and then the y-intercept is 1, so plus 1. Now remember, the other one was y equals 3/5 x minus 4. So let's look for the slope now. The change in the y is 1, 2, 3, and then change in the x is 1, 2, 3, 4, 5. So we get 3/5. All right, so how are those lines related to each other? Well, it looks like they have the exact same slope. All right, between here and here, 3/5 is the slope on both of them. So they have the same slope. And also, when I compare the two lines, or when I look at the relationship between two lines, I know these two lines are never going to cross each other, because this one goes up 3 and over 5, and it's not going to get any closer to this one because this one's also going to go up 3 and over 5. So since they have the same slope, as this one's going up at the same rate. So they never catch each other. So that means those are going to be parallel to each other. All right. What else you got for me, problem? Now they want me to rotate the pre-image, so the blue line, 90 degrees clockwise. All right, so we talked about 90 degrees clockwise in one of our lessons. Let's do this one in green. So if I go 90 degrees clockwise, remember that that's this direction right here, so I'm going to go this direction over there, 90 degrees. And we talked about how the coordinate notation for that, well, we could do it as coordinate notation where we can spin our graph to see where it would end up. There's a whole bunch of different ways that we could find out where that would be. So whichever method that you use, this point would be right here. And you can see that because if we spin this 90 degrees this direction, the blue point is now at the coordinates -4, 0. And that's where it is here. Okay, this point right here, right now, it's at 1, 2, 3, 4, 5, -1. Let's spin our paper 90 degrees, and now it's at -1, -5. So -1, -5, -1, 1, 2, 3, 4, 5 would be right there. Okay, so we've got a new line. We have rotated it 90 degrees clockwise. There's our new line. Okay, so this is 90 degrees clockwise rotation. Remember, one of the ways to find out what the new coordinates are, if we're going 90 degrees, the x and the y were always changing. And if you know that you're going to be in this quadrant here, 5, 1 becomes in this quadrant -1, -5. So we're just switching the x's and y's there. So -1, -5. Anywho, moving on. So, calculator got in the way. What is the equation of the image? Okay, well, we'd have to look at its slope. It looks like this slope goes down 1, 2, 3, 4, 5, and over 1, 2, 3. So it goes -5, 3. What am I doing? -5 over 3. It's a rough day, trust me. So we've got a slope of -5 over 3. Now we know that we're passing through the point -4, 0. So we've saw in the past how we can just use the y equals mx plus b equation. To solve and find out where the y-intercept is going to be. So our y value is 0. Our m value is -5/3. Our x value is -4 plus b. So -5/3 times -4 would be +20/3. And then I'd subtract 20/3 from both sides and I get b is equal to -20/3. So the equation of this line would be y equals -5/3 x minus 20/3. All right, I'm off my game today, but we'll get there. We'll get there. All right, so how do the slopes compare? Well, we know that our slope of our new rotated line is -5/3. We knew that this line was 3/5, and we knew that the other line up there was parallel, and it was also 3/5. So what we see here is we got 3/5 and -5/3. It looks like the x's and the y's have switched the places, and one's become positive and one's become negative. Now remember, the coordinate notation for what we just did was -y, x. So what's happening? Well, the x and y are switching places, and we're switching our sign on the y. Well, look what happened to the slopes. The x and the y's are switching places, and one's going from a positive to a negative. So it has something to do with that. So what we notice about their slopes, if I've got a slope for the original was 3/5, and the slope for the copy, the image, was -5/3, we call those opposite because one's positive, one's negative, or some books call it like negative. So we know those are opposite, meaning one's positive, one's negative, and we notice that they are reciprocals of each other. The numerator and the denominator have switched places. Now we already talked about this. When we rotate 90 degrees, we create 90-degree angles. We call that perpendicular. So these two lines are now perpendicular, and even these two lines up here are perpendicular. So one way to check to see if your lines are perpendicular is to look at the slopes. -5/3, 3/5, those are opposite and reciprocal, so those must be perpendicular to each other. And that was the answer up here. How are they related? They're perpendicular. All right, moving on. It says on a piece of graph paper, again, really? It says make 3 lines with slopes of 1, 1/3, -3/4. Let's just do 2 of them. That just seems excessive. So I'm going to make a graph here. All right, let's take a line with a slope of 1. So I'll start here and go up 1 over 1, up 1 over 1, up 1 over 1. There we go. So there is a line with a slope of 1. We made the line y equals 1x, or just x, minus 1, because our y-intercept was -1. Okay, and then they say rotate them either clockwise or counterclockwise and observe what happens to the slopes. So we already know that this slope is 1. Let's take this one and let's do, we'll do counterclockwise. So go this way 90 degrees. So this point would end up here, and this point would end up here. So here's our new line, because this one rotated this way to here, and this one rotated this way. Remember, we're rotating around the origin, so they're always keeping that distance to the origin. So we see a 90-degree angle here. Well, what's the equation of this line? That line is y equals -x, because it goes down 1 over 1, -x plus 1. So our slope was 1 over 1, and it became -1 over 1. Those are opposites because one's positive, one's negative, and they're reciprocal because the numerator and denominator have been switched. It's harder to see because they were both 1, but it is happening. All right, let's do one more. Let's do this -3/4. All right, so we're just going to make another graph, and we're going to make this one have a slope of -3/4. So I'm going to start here. That's going to be my y-intercept, and then I'm going to go down 3 over 1, 2, 3, 4. All right, so I just made the equation y equals -3/4 plus 3, because my y-intercept was 3 and my slope was -3/4. So this is y equals -3/4 x plus 3. All right, now we want to rotate this. Let's do it clockwise this time. So we're going to go this direction. So again, you can spin your paper, do whatever method you've been using. So this one is at 0.3. If I rotate it, it's going to come around to here in the rotation. This one, rotating it, is going to come down to here. It was at 4.0. Now it's at 0, -4. Okay, so we've got our new line here. This is our rotation of 90 degrees, and this time we went, clockwise. Again, we're getting that nice 90-degree angle right there. So they're perpendicular to each other. Now let's find the equation of this line. This one goes up 4 and over 3. So this would be y equals 4 over 3x, and then the y-intercept is -4. Now look at these slopes. 4/3 and -3/4. Those are opposite, meaning that one's positive, one's negative, and they're reciprocals, meaning that the numerator and denominator have switched places. So, what do we observe? We still observe that the slopes are opposite reciprocals when we graph them. No matter what we graphed, we're getting opposite reciprocals with these. The other way to look at it is also, if you multiply two slopes and they're opposite reciprocals, you will always get the answer of -1. So remember on the first one we had the slope of 1, and then that became the slope of -1. 1 times -1 is -1. That means they're opposite reciprocals. The other one we had -3/4, and our other slope was 4/3. Multiply these going across, and you get -12/12, which is -1. So anytime you have opposite reciprocal slopes, their product, so multiplying the two slopes, will always be -1 when they're opposite and reciprocal. All right, number 28. What is the slope of the perpendicular line? All right, so this is a little bit crazy here because they don't give us any numbers, but we can do the change in y over the change in x and find out what the slopes are, just using the letters. Look at this first one. What's the change in y? This distance is a distance of a, so I put a in the numerator. This distance here, it's b. We know that this is a positive slope because it's increasing from left to right. Now let's look at this other one. If it's perpendicular, we know that the b would go over here, but it's going downhill, so this is -b. And then we know that the a, if I go 90 degrees, this segment would be a. So what's the slope? Well, it goes down b and over a, which is -b over a. So the slope of that perpendicular line would just be the opposite and reciprocal of the original line. Opposite because this was positive, this is negative. Reciprocal, a and b switch places. All right, let's see if we are ready for the next step. Next steps. 3-29. We want to write the equation of the line that goes through the point 0, -3 and is perpendicular to this line. Now, if it's perpendicular to this line, what does that tell us? Well, it tells us the slopes must be opposite and reciprocal. So what's the slope of this line? This line is -2/5. Well, what's the opposite reciprocal of -2/5? Well, opposite would be positive. Reciprocal, it would be 5/2. So this, they were nice enough to give us the b value, because remember when x is 0, that's the y-intercept. So our equation for this line would be y equals 5/2 x minus 3. So from this line here, the only thing we used was its slope. We don't care about its y-intercept. That doesn't help us. Perpendicular means opposite reciprocal slopes, has nothing to do with the y-intercept. So we just did the opposite reciprocal. That told us that our slope must be 5/2. and then they gave us the y-intercept. All right, next one. Write the equation of the line that's parallel to this one. So this one has a slope of 3/2, and it goes through the point 0, 7. Well, they're nice enough again to give us the b value, 7. Well, if this line here has a slope of 3/2, we said with parallel lines, the slopes are the same. So our line also has a slope of 3/2. So our line would be y equals 3/2 x. There's the slope because they're parallel, they have the same slope. But the y-intercept for this one is 7. So much deliciousness. Next one. Okay, we're just gonna sketch this one out. All right, there's a lot of stuff they're trying to confuse you, but they're not gonna. Y-intercept is -10. I'm gonna go down here. That's -10 because I said so. And then we're gonna go, our change in y is 6, our change in x is 5. So I'm gonna go up 6, I think that's about 6, and this is 5. I don't really care if I'm accurate. There we go. So there's A. So A is this one, and this is y equals 6/5 x minus 10. All right, so now they're saying line A is parallel to line B. I don't know where line B is, but I know it's parallel. That means they're going to have the same slope. So whatever B is, B has a slope of 6/5. All right, reading further. B is perpendicular to C. Okay, perpendicular. All right, let's put it right here-ish. And a new color. Blue? Yeah. All right, there it's perpendicular. This one is C. Now C must have the slope of -5/6. Reading on. If D is perpendicular to C, so D's perpendicular to C, you're really making it difficult for me now. All right, so I need to make D perpendicular. I'll put D right about here-ish. So D is perpendicular to C, so D must have a slope of 6/5. If D is perpendicular to C and it's perpendicular to E, so it's also perpendicular to E. What color have I not used yet? Orange. So D, this one, is perpendicular to C, and it's perpendicular to E. Well, this looks like now C and D are parallel to each other, so E's slope has to be -5/6. So what's the slope of E? -5/6. Thank you for trying to confuse me. It didn't work. All right, last one, learning log. Summarize your findings for the slopes of parallel and perpendicular lines. Well, we know that parallel lines have the same slope. Perpendicular lines have opposite and reciprocal. And that's pretty much all we learned. We did a lot of work, but that's basically what it comes down to. Now there is a methods and meaning section to this as well, so you're going to have to watch out for that. It's in your book. This is just about naming different shapes. So these are like the conventions that we use to name something. So a corner, so like this angle right here is called A, so we call that a vertex. Okay, so there's a lot of different things that we do when we name stuff. So when we've talked about already how if we make an image and a pre-image, so this is a pre-image of A, and to show that it's a copy, we put A prime. It's called prime notation. Okay, so when we name triangles, we just write the triangle symbol, and we have ABC to show the different vertices or vertexes of the triangle. So that's how you name a triangle, is by saying the shape triangle and then the 3 letters that make up the triangle. A line segment, so that has a stopping point on both ends. So like if we had a line segment that had a starting point here and a stopping point here called AB, this one we would call AB with a line over it. Now AB would be the same thing as BA. They're the same shape, right? AB is the same thing as BA. So when we do a segment, you always put a line segment over it. Now when we want to talk about its measurement, so if we want to say what is the measurement of that, the symbols for measurement is just the letters AB without the line. So if this were 2 centimeters right here, then we would say AB without the line, so its measurement equals 2. Lines go on forever, so when we have a line, we can pick any letters, 2 letters on that line. So if there were a third one over here, we could call this line DE. Now, you can't really see it very well on here, but there's arrows at the end here. So that means it goes to forever in both directions. We could even call this line DF if we wanted to. It'd be the same line because it goes forever. We could call it FE. We could call it DE if we wanted to. All of those would be the same exact line. So the order isn't important in lines. Finally, angles. When you have angles, you can't call this 10-degree angle here angle G. The reason is I wouldn't know which angle you're talking about. Are you talking about this big angle, this small angle, or the whole thing altogether? You can't just name it angle G because then you'd confuse people. So if I wanted to name this 10-degree angle, I would use 3 letters. I'd start with the H, G, and then I. So here we see angle HGI. That's one way to call it. I could also call it the other direction, IGH. Whatever the vertex is of that angle, the corner of that angle, that's the letter that goes in the middle. So if I wanted to name this angle up here, I would name that FGH with the angle symbol in front, or HGF. So notice that the vertex was always right in the middle when I named it. Now if we want to talk about how this one is 10 degrees, we would put the M in front to say that we're talking about its degrees and not that we're just pointing to that angle. So this means the measurement of angle HGI, and that equals 10 degrees. All right, that's all I got for you. Go forth, do math, be happy.